What is an atom, really? It's the basic unit of matter, the building block of everything around you. From stars to skin cells, from mountains to molecules, everything is made of atoms. But they're not little marbles of stuff. They're a structured system of charge, mass, and space, held together by fundamental forces. And once you understand how they work, you start to see what everything else is built on. An atom has three main parts: protons, neutrons, and electrons. At the center is the nucleus, tiny, dense, and packed with almost all the atom's mass. Protons live here. They carry a positive electric charge. Neutrons are also in the nucleus. They have no charge. They are neutral. Now, here's something important. Protons repel each other. They all have the same positive charge, and like charges push apart. So why doesn't the nucleus just fly apart? That's where neutrons come in. They make room for the strong nuclear force, one of the four fundamental forces in nature. Not all atoms of an element are exactly the same. They always have the same number of protons. That's what makes them that element, but they can have different numbers of neutrons. These versions are called isotopes. For example, all carbon atoms have 6 protons, but some have 6 neutrons. That's carbon-12, stable and common. Others have 8 neutrons. That's carbon-14, which is radioactive. Same element, different mass, different behavior. Now, let's move away from the nucleus. Electrons are much lighter than protons or neutrons. They carry negative electric charge, the opposite of protons, but they don't orbit the nucleus like planets. Instead, electrons exist in a cloud-like regions called orbitals, zones where there's a high probability of finding them. We can't pinpoint exactly where an electron is, but we can map where it's most likely to be. These regions are shaped by energy. Different energy levels hold electrons at different distances from the nucleus. And those electrons, they're responsible for chemistry. They form bonds, they create molecules, and drive reactions. Life itself depends on how electrons behave. But here's the wild part. Atoms are mostly empty space. If an atom were the size of a cathedral, the nucleus would be like a grain of sand floating in the middle. The rest, just space, shaped by probabilities and electric fields. So why does matter feel solid? Because of electromagnetic forces, the interaction between charges. When your hand touches a surface, your electrons repel the electrons in that surface. There's no physical contact, it's electric fields pushing back. The atoms don't collide, their charges and fields do. So the atom isn't a little ball of stuff, it's a stable structure of mass, charge, space, and the laws that hold them in balance. And you're made of atoms, which means you're not made of solid matter. You're made of space, energy, and the rules that hold the void together.